All right, this lesson is on scientific notation. This does come up quite a bit, and not just in this class, but in your other science classes. So you want to be able to express, we use scientific notation to express really, really big numbers and really, really small numbers. And so it uses powers of 10 to do that. And so we know when we multiply a number by 10, it shifts that decimal point over, right? So if I said 5 times 10, that's 50. 5 times 100, that's 500. 5 times 5 times 1,000, well, that's 5,000. So every time I multiply by 10, it just shifts that decimal point over one place to the right. Similar when I divide by 10, it shifts it over the other way. So let's write this in what's called scientific notation. So powers of 10. So instead of 42,000, what we do is here's our sort of our definition. We're going to do a times 10 to some power. And that a is always between 1 and 10. It's a single digit number. So in this case, if we look at this first example, 42,000. So I know it's going to be 4.2, and we go all the way out to the last non-zero number, generally, unless you are given some additional instructions. So 4.2 times 10 raised to what power? And the question is how many places do I move that decimal point? Well, it started here. So we did 1, 2, 3, 4 places. So 4.2 times 10 to the fourth. Because each time I multiply by 10, it shifts that decimal point over. How about this one? So we know this is going to be 5.6 times 10 raised to what power? We can count them. And we can kind of count them in groups of 3 if that's easier for you. So we got 1, 2, 3, 4, 5, 6. Now, how about really small numbers? Well, here we're just going the other way. So we're going to go 1, 2, 3, 4 places. So I know this is going to be 5.6 times 10 to the negative 4. Now, really what we're doing is we're dividing by 10 each time. Recall negative exponents. All that means is I'm dividing by 10. So this is the same thing as 5.6 divided by 10 to the fourth. With scientific notation, though, we will always write it as times. And so rather than having it divided, we shift that up to the numerator and make it times, and we change that to a negative exponent. How about this one? 0.0098. So it's going to be 9.8. Remember, I go until this digit here is a one-digit number. So all these are just one digit, single digit, decimal, and then whatever else I have here. I just have one more digit. So times 10 raised to what power? This moved 1, 2, 3 places. Okay. Now let's convert to standard form. So this is called standard form. Here's scientific notation. We want to be able to go back and forth pretty easily on this. So 3.2 times 10 to the fourth. So I'll start off with 3, 2, and then I'm just going to be adding zeros, right? So how many zeros? Well, not 4 zeros, because I already have one place value here, right? So it's going to move 1, 2, 3 places. So we got 1, 2, 3, 4. So I've got 4 places it's going to move. Sorry, I think I said place before. I meant it has 3 zeros. We already have a placeholder there. Now, we usually don't want to write the number with these little bloops here, so I'll go ahead and rewrite that, and I'm going to put my comma in. Makes it a little easier to read. Similar, how about this one here? Now to the negative exponent, so we know it's going to be a really small number, less than 1, and so it's going to be 0. Now think about this. This is going to move over 3 places to the left. 1, 2, 3. And so I fill in zeros right there, so it's going to be 1, 2. I hope that helps.